Okay, our fourth subtopic, which is on interference of reflected light in thin films. So in this subtopic, you should be able to identify the occurrence of phase change upon reflection. So there will be a phase change if a light is being reflected lah uh, untuk lower to higher refractive index. There will be a phase change of pi radian ataupun path difference of pi over 2 lah. Lambda over 2. I need this. And then you have to also be able to describe with the aid of the diagram the interference of light in thin films at normal incidence. Okay, so we only gonna be limited to 3 media lah. So A glass ka, and then A balik gitu lah. So you also need to be able to use the following equations with no phase difference, usually for non-reflective coding. So constructive interference ini, destructive interference inilah. And then also use these two equations for reflective coding. And then coating. So lastly, you have to be able to explain the application of thin films. For example, it is used in solar panel and glass tint. Okay. So interference of reflected light in thin films. Interference due to reflected waves are observed in our everyday circumstances. For example, we can see bright colors from oil film on water kan. Contohnya kalau kamu nampak puddle of water and then sometimes you could see different colors on the water. This is actually interference due to reflected waves lah. Also soap bubbles, you could see like a rainbow like colors kan kalau nampak di soap bubble. Now the reflected waves can change their phase by two ways lah, in two ways. So the phase change in proportion to the distance of the waves travel. Okay, so the distance would affect the phase change, and then the phase would also change due to the reflection process itself lah. Okay, so optical path is defined as the product. So this is optical path. So this is defined as the product between a distance traveled by light and the refractive index. Kalau ada orang tanya, optical path, that is the equation lah. Okay, and then let's look at the phase change due to reflection. Okay, let's look at figure 7. So figure 7 has a pi radian phase change because the light is traveling from a lower refractive index to a higher refractive index. So the refractive index here is lower, this one is higher. Okay, so there would be a phase change lah. Berapa banyak? Sebanyak pi radian. And then for this one, this is higher and then this is lower. So if a wave is traveling in a medium of higher refractive index going to a lower refractive index punya medium, it will not undergo any phase change. Okay, all right. Okay, so now let's look at interference from thin films on a denser medium. So this is denser medium. So this figure is showing us the light wave being reflected from the upper and lower surface of the thin film lah. So when an incident rays falls on this thin film surface almost normal to the surface, which is at point B here, a division of amplitude occurs. So division of amplitude occurs means there will be a two reflection lah, and then part of the ray will be reflected, which is this one here, and then part of the ray are refracted here and then reflected back. So point D here is very close to B. It could become so BC and CD becomes a straight line lah. So at point B here, which is this point here, the reflected ray will undergo a pi radian phase change because it is going from a medium of lower refractive index to a higher refractive index. Okay, and then point C pula, which is this one, the reflected ray will also undergo a phase change because you can see the first medium is lower than this medium. Alright, so both of these ray 1 and 2, this one and this one, are two coherent sources in phase because the phase difference is pi minus pi lah. So they meet at a point which would produce an interference pattern lah. So the optical path difference between ray 1 and 2 is given as this one lah. This is the optical path difference. So in order for you to calculate constructive interference for denser medium, you will use this one, and destructive you will use this one. Okay, so example of thin film on the denser medium is a anti-reflective coating ataupun oil film and water lah. For thin film on the less dense medium, soap bubbles ataupun reflective coating. Okay. So interference from thin films on a less dense medium pula. Kita tengok less dense medium. So just now denser medium, kita akan tengok dia punya this one is denser, and then this one is less dense. Untuk this one pula less dense medium, satu saja yang dense punya medium. Alright. So again, when a light is reflected here, there will produce a division of amplitude lah. Okay, so part of the ray will be refracted as ray 1, and then the rest is refracted and reflected lah. Okay, so at point B, this one will undergo a pi radian phase change lah. And then why? Because it is reflected from a lower to a higher refractive index, and then at point C there will be no phase change because it is going from a higher medium to a lower medium. Okay, so both of these two rays are two coherent sources but in anti-phase lah. Okay, I forgot to put anti. So both of these are coherent tapi dia dalam anti-phase. Okay, with a phase difference of pi radian lah. Okay, and then the optical path is shown here. The formula is shown here lah. Okay, and then for constructive interference, you will use this one for less dense medium, and then this one for destructive interference on less dense medium lah. Okay, that is on subtopic number 4.